Honors class, this is the last one of the problem set. This is number 60. I know the calendar says there's a number 72, but we're not doing that one. So we're going to just push on through with number 60 here. An iron ore sample contains Fe2O3 together with other substances. Reaction of the ore with CO produces Fe metal. Okay, so here's our not balanced equation. Our first step, and you will see there are many times when I ask you to do something like this, you'll be given an equation. Please balance it. That means when I come through here to balance this, I do this, 2 and 2. Notice I have one carbon. I have, this is going to be a problem. So for my oxygens, I have 3 here plus 1 here is 4 on this side, which means I need 4 on that side, which means I need a 2 here, which means I need a 2 there, which changes the number of oxygens that I have. So what if I do one more step? What if I do 3 and 3? Now if I do 3 and 3, I got 3 plus 3 oxygens here is 6, and 3 times 2 is 6. So that one actually works out just fine. All right, so my balanced equation then is 1, 3, 2, 3. Good. So let's keep going. Calculate the number of grams of CO that can react with 0.15 kilograms of Fe2O3. So I start off with the same thing that I've always done, except this time I have to change sometimes when given kilograms. That has to be changed into, I go 1, 2, 3 places to the right. Why do I do that? Remember this all the way back. Before, this is kilo here, and this is grams, meters, liters, like this. So from kilo to grams, I go 3 places to the right, which means I have 150 grams of Fe2O3, like this, over 1, and now I start my problem. Now, this is a mass-to-mass problem, so my first step is to change from grams of Fe2O3 to moles of Fe2O3 like this, which means that there's some amount of grams I'm going to need. So we'll have to do that. I need a little bit more room here. Like that. So Fe and O, 2 and 3, 16.0 is 48 times 55.9 is, who knows, what is that, like 111.8? No, I think I just made that up. I think that's pretty close, actually. So 55.9 times 2, 111.8. Ha, Bensing. So, moving on, I add them up, plus 48 equals 159.8 grams. Now that's just to go 2 moles. So now I have moles of, and look what I'm going to need. I'm going to need the balanced equation, so I'll keep it right there. Now I'm going to I'm looking for CO, which means that here I have 1 mole of Fe2O3 because the 1 mole is the coefficient in front of Fe2O3, and 3 moles is the coefficient in front of, just like that, of CO. Now my last step is to do 1 mole of CO on the bottom, so I get number of grams of CO on top. So C and O, 1 and 1 times 12 is 12 times 16 is 16. That looks like it's 28 grams per mole. Okay, so now I'm going to get an answer down here. So that's all going to equal what? So 150 divided by 159.8 equals, and then times 3, and then times 28. And that gives me a number of 78.8 grams of CO. That's letter B. Let's see what letter C has to say. Calculate the number, like that, grams of Fe and CO2 formed when we have the same thing. Okay, well, I guess I can just start off. I'm going to do the same conversion here. of 1, 2, 3, like that. So I got 150 grams of Fe2O3 like this over 1. I do the same thing. Matter of fact, I can do this twice, like that. My first step is always the same. I go from grams to moles. This is going to go a little quicker because here I got the 159.8 grams. I already know that. 159.8 grams for 1 mole of Fe2O3, like this. Okay. My next step, the first one is saying grams of Fe. Now Fe is right here, so that means my 1 mole of Fe2O3, like that, on the bottom for both of these. And where are we at here? Now the first one is Fe, so that's 2 moles. Oops, yeah, that's it, of Fe. And the next one is CO2, which means 3 moles of CO2, like that. Now this one's pretty easy because 1 mole of Fe is 55.85, which is 55.9. Come on, there we go. 55.9 grams of Fe equals. This one, though, does require us to do our CO2, so that's 12. That's times, 16, which equals 32, and 12, which is 44. So this will be 44 grams of CO2 for 1 mole of CO2, like that. So I go through this, same thing as before, 150 divided by 159.8 equals that times 2 times 55.9. So I get 104.9 grams of Fe here, and I do the same thing here, 150 divided by 159.8 equals, and then times 3, and then times 44. And I get 123.9 grams of CO2, just like that. All right. Not simple, not easy, but it does follow a pattern, does follow a list of steps that you guys can all do if you practice. So just quickly, you guys have a Chapter 3 test coming up. What kinds of things do you need to know for the Chapter 3 test? Obviously, you're going to have to do molar mass. That's what this example is here. It's also called formula weight. It's also called molecular weight. It's also called molecular mass, blah, blah, blah. Okay, we've already talked about all the different things there. So you should be able to do conversions of mass to mole and moles to mass. And also, you should be able to do conversions using molecules. That would be the 1 mole equals 6.02 times 10 to the 23rd, either molecules, we call that just particles to be generic, okay? So 1 mole equals Avogadro's number. You should be able to do that. Percent mass is like number 24 from 3A problem set. You should be able to do a percent mass. It's easy, it's not difficult. The empirical formulas are the ones we just worked on. That was number 40, 49, and 50. Balancing and identifying reactions. Guys, we spent a lot of time balancing and identifying reactions. You should be able to do that. There may even be some predicting products like sheet 4, 5, 6, and possibly 7 on there. And I think that's it. Okay, this is just an example of a limiting reactant. There are no limiting reactant problems on the chapter test, but you should be able to do a mass-to-mass problem. You should be able to do mole calculations. Okay, good luck. We'll talk to you later.